And good morning, good afternoon, and good evening, everyone. Today we are going to talk about the rapid prototyping automation for insurance operations. And we will build something very, very practical today. And what I want you to walk away with is a sense of how you can build automation on top of your existing Actuarial modules. So for that, we will use a pretty simple tech stack, n8n, Python, and FastAPI. And so you will see we will build that pipeline in n8n so that at the end of the day you are able to replicate that. The pipeline will be in three parts: the trigger and the third-party data collection. We'll see how we can collect data using some APIs from external sources. We'll see how we can push those data into your actuarial models, and then how you can do some triage and send one email to your operations. And so as a use case today, we will assume that we are a travel insurance company and that our core exposure is, let's say, the number of travelers traveling to different airports at different day. So let's assume that you have access to, in your portfolio is composed by airports, and for each day for each airport you have a certain number of travelers. All of that data are completely dummy data, right? Randomly generated. So don't quote me on those numbers. This is just to build something that is interesting. So this is your risk exposure, the number of travelers per day. And the use case is, what if you want to add some catnet events analytics on top of this pipeline using third-party data, just like Google Weather Lab. So let's assume this is the beginning of the hurricane season and there is a hurricane that is developing, and you are using Google Weather Lab predictions in your model. And the main output should look like something like that. So you have the path of your hurricane, and based on the path of your hurricane, you are basically computing the number of travelers at risk, the number of airports impacted, and also you want to send an email to your operations to say, hey, as of this date, this is the number of people that will be impacted, the number of airports, and the list of airports. Okay, so this is the use case. And finally, what we really want to do, and this is what I'm writing here also, is we don't want to have any manual intervention in the pipeline. So that service or this solution should be able to extract the data to integrate it with your model. So we really want to build that by the end of today. And yeah, we have a lot of work, so let's get started. But just a little bit before we can get started, my name is Stefan Fedor. I will be your guide today throughout how we can build this automation. I have 15 years of experience throughout, in France and also here. Right now I'm American. I'm living the best life in California. And I've spent a lot of time solving those problems for insurance companies in life, health, and P&C verticals. So yeah, I'm super happy to be here, and we will learn a lot of good stuff together, hopefully today. What I think is super interesting in that use case is, most of the time when I go to one actual department, they are very good at building in-house predictive models. So maybe you have your Excel spreadsheet or a Python module, something that is sitting somewhere and doing some forecasts, some predictions, right, to estimate your risk. But what if you want to make that business logic more scalable? What if you want to integrate with other data sources? And this is the three main pain points that I see throughout the actual departments. So the first one, as I said, is how you can ingest new data. In that use case, how you can ingest data coming from Google. And I think this is something that is, I'm digressing a little bit here, but this is something that we will see more and more and more as with AI and new advanced technology, where you have the private sector that are, investing a lot and competing to produce, very, very good forecast model. So for example, Google DeepMind is setting, as of today, a new standard for the weather forecasting. So we had quite a lot of articles in 2025 showing that those models from Google from the forecast for the hurricane in the US are outperforming the conventional weather forecasting methods for the first time. So that was interesting to see. And we can expect, to see those use cases showing up more and more and more throughout the insurance industry. So we really want to be able to leverage those new predictive models coming from other sources and to integrate them into our pipelines. So this is the first pain point. The second pain point is how you can turn your model into business logic, into pipelines, how you can have something that is production ready. Most of the time, it can feel like the actual models are a little bit disconnected, at least from the operational pipelines. So how you can create something that is integrated and very accessible to your company. So this is the second pain point. And the third pain point, this is something that that is close to my heart, which is how fast you are able to integrate new ideas into your pipeline, how modular you are thinking about your approach, and how you can integrate those forecast elements within your existing infrastructure. So we are talking about ecosystem here. And you will see with n8n, this is something that, this is why I chose n8n for this use case and this presentation, is because let's say you have built one module, let's say this is an API that will retrieve the data coming from the weather. What you can do right off the bat is you can copy paste that block and use it to into another pipeline, right? So those tools, n8n, this is a low-code tool with you just basically plug and play, are becoming increasingly powerful. Okay, so this is the main pain point that we'll solve today, at least an illustration of how you can solve it. I'm not saying this is the only way of doing it, but this is how you can solve it. So let's dive in. Before we can start to implement the solution, what I think is critical is to build a framework. What is the framework? And let's design the framework that we'll use today. So basically we have the first component, an in-house predictive model. What we will also want to do is to integrate, I would say, Google Weather Lab data. So if you are not familiar with Google Weather Lab data, you can go to deepmind.google.com /science/weather-lab, and basically this is a way to have access to their forecasts. So you can see the active storms, or you can just jump to the historical storm here. And basically when you click on one storm, so you will have a bunch of information you can see here in download data, and if you click here you will get access to one CSV. But so this is the raw data that will be here, but of course what we want to do is to have a way to automate that. Okay, so yeah, before I go further, let's say this is the predictive layer. So we have two components in our predictive layer. the data coming from Google and your in-house predictive model. Okay, so this is where you forecast your stuff, and Google is forecasting, you know, the path over time here per 6-hour increment. Then on top of the predictive layer, we want to have our automation layer. And the requirements for this automation layer, basically we want to run this pipeline on a daily basis during the hurricane season in the US. So let's say daily, yeah, starting from June, let's say, to November. And of course, the data that we just have here from Google that we want to integrate, we can't only deal with an extraction of a CSV at a time because it's too manual, it doesn't scale, and more importantly, this is not super easy to integrate into n8n right off the bat, or at least to connect it to your predictive models as well. So just for today, we will create some APIs on top of the Google Weather data, Weather Lab. And so that's going to be the first API that we want to create. Then we know that at some point we'll have to format the data that are coming out of the API that we will build. So those data will be an input for our model, right? So we'll see how we can format the data in n8n. And then what is also interesting is we will build an API on top of our predictive model that is predicting basically the risk exposure, meaning the number of travelers impacted by a hurricane. And then what you want to do when you have formatted the data, you want to do some triage so that your operations are not receiving one email per day that is not relevant. So you only want to filter the events that are, you know, significant for you. And then you want to send email. Okay, so this is the pipeline, very straightforward, but we will highlight, I think, a lot of good points here, which are how you can create an API in a way that is super efficient here. So we'll see that. And the second part is how we can replicate what we've learned in the first step, and to do that for our predictive models, and basically for any predictive models. So by the end of the video, you will be able to take your actual model and turn it into one n8n component and to reuse it as you wish throughout different pipelines in your organization. Okay. So now, oh yeah, just one point. This is the tech stack I've already mentioned. We'll use n8n, which is a low-code tool, Railway to host the APIs, and Python and FastAPI, which is a Python module on top of Python to create APIs very easily. Okay, so let's do that. Let's see how we can do that. So first, what we are going to do is we are going to create a new pipeline in n8n. So let's do that. And let's create a chat. And in the chat, basically at this point we will only send the date. Okay, so the chat, so if you are not familiar with n8n, basically with n8n you can create modules and connect modules together. Um, I'm just taking that. You For each module we have the input, the logs here, and the output. And the output, they are in a kind of a JSON format all the time. And what is nice is you can reuse the information from the previous modules to your step very easily using some drag and drop or some JavaScript expression. It's a good mix of modularity, and also something that really helped n8n to take off. Last year is all the AI components. We won't have time to explore it, but I'm just mentioning it. If you want to play with that, is you can, when you have built your pipeline, you can easily plug in different agents or AI agents to start to enhance your pipelines with AI if this is something that you want to. So you have access to a lot of models, you have access to a lot of features without being super technical, which is very nice. So I'm digressing, and let's go back to what we want to do. So basically you are sending one day here in the message, and obviously in the final version it will be something that will be triggered on a daily basis, right? But let's start with the chat component. Then what we want to do is to implement a solution to retrieve the data from Google. So let's go to my dev environment, and let's work on that. I will show you how we can do that. So here I've already prepared the stuff for you, but we have access to some Python codes, and I will show you the logic and how you can build very quickly one API that is extracting the data, as I said, from Google Weather Lab. So you will have access to this code, but very high level, the way that you define an API in Python. And if you are not familiar with that, there is an amazing resource that you can go watch after this video. It's from Dave Ebler. I'm putting that here. So shout out to this guy, because I've learned a ton watching his videos, honestly. So you can go to those links and you will be able to have more details about it. But my goal is not to turn you into a software engineer, right? My goal is to show you, hey, don't be afraid. That is super simple. You just need to follow some steps, and you will be good to go. So let me open a new terminal here. API demo. All right. So first of all, you want to extract the data from Google, right? So you have this file, which is 200 lines of code. So basically, if you've seen Google provide you with one URL, and that URL, you use that to parameterize the URL and to extract some CSV. And in the CSV, it's basically the path of each hurricanes. So for each date, you will have what is the forecasted or predicted path of each hurricane. Very quickly, what you want to have, I'm defining some functions here, how you can create dynamically the URL, and I'm packaging that into one Python class. Nothing very fancy, but basically here you get the URL given the date, and you send a request. You download the data in the buffer, because sometimes the data can be maybe too large. So you do that, And then this is something that is also critical, is the way you want to display the data, or to use the data. So I chose some options here to basically format the data in a way that I will always have, the I will show you later, but you will have the hurricanes and the path of the hurricanes per day. So this is, but this is your secret sauce. You do whatever you want. This is the way I've done it. And then you run this line of code. So let's see, Python 3 data feature. So it's downloading. Boom. So this is the raw data. So it's working. So basically you have here your core logic, okay? And now how to turn that into an API that I can interact with in n8n. So there are a couple of things that we want to do. First, you see it's super straightforward. The first file that you want to create is the main file where you create this fast API component. You create your fast API and you include one router. Basically, the router is defined here. Think about it as a function where you give a date here, and basically all those lines of codes are the one that you've seen here in the main running. So basically what you are already doing here, you are encapsulating it under the router and with this parameter, which is the date. So in that data feature, I was putting here the date manually just for testing purposes, right? But think about it now, it's dynamic, so you change that by date in your router, and basically we define do those operations and display the result as is. So once you have something like that, that's good. And what we will use Railway to host that simple API. So Railway is a service. Let me show you. Let's head over Railway. You can host, let's see, the dashboard. So we will basically we will create one new project here, and that is linked directly to our code. So I don't want to spend a lot of time on that, but basically this code is hosted in GitHub, and Railway connect to GitHub so that we can push the repo into to Railway directly. And whenever you modify this repo and basically you commit and you push, you merge with your main branch, basically the application will start again. So basically everything that you change here will be reflected in your Railway application. So you need one Docker file here. You can ask ChatGPT, hey, how to parameterize this Docker file to make it run in Railway. It will show you this, and railway.toml just to say, hey, use the Docker file to build it. Anyway, this is some DevOps stuff that you can't ignore, but this is this is only two files that you need to care about. So now let's use Railway to use that API and to see what we get out of it. So let's start a new project here, and it's from GitHub, and this is the name of my repo, and basically it will start deploying the repo, and it will take 1 minute to do it. So while we are waiting for it, I will just maybe go through what the API should look like. So let's wait. Let's see what we get. Oh yeah, let me show you something that is also, I think this is super important to have, and maybe you are already familiar with Streamlit. Streamlit is something that I really love. This is a way to create small, web applications on top of your data science project, where you can show to your let's say C-levels or people other from other departments. You can show your project. So it's you write your code in Python on top of it, and I just wanted to show you the end result. This is the end result that you can have with some Streamlit applications. So this is not super fancy, but it's good enough to display data, to play with data, and to show people, hey, basically this is a dashboard tool, right? So you will also have access to the code of this small application if you want to have an introduction of Streamlit. Okay, so the way it seems that everything worked, the deployment has been successful. Let's see. Yes, no bugs so far. So what you also want to do is to generate one domain here in a railway. So we'll have here one domain name. And what is great with Fast API is if we go docs, so basically it creates the documentation right off the bat for you, which is a super nice feature. So remember get data, it was the function that we were basically implementing in the router. So it was to here, get data. So basically we give a date, and if we give a date, we should see those kind of data in the right format, right? So let's try it out. When we enter this date, execute it, and it works. Okay, so this is your data. So your API is working, you're super happy, and now let's head to n8n. So what we want to do in order to interact and to retrieve the result in n8n, we will use a HTTP request and get weather lab data API number 1. And one way of doing it is you can use the curl here. So the curl is that expression that the API documentation is giving you, so you can use that. That is a super nice feature. You copy paste it here, and basically it will set up your HTTP request module for you. You execute the step, and boom, you have access to the data now. Okay, so this is the data you have access to, and you can see this is the date, etc. Now this date is fixed, and I want this date to be manual. So basically I remove it, and I take this field here, and I execute it. All right, it's working. Let me save that. Oops. So now let's see if I send another date 070, I don't know. maybe I should look at, when was Helen, when was that? September 23rd. Okay, let's try it with this guy. Okay, September 23rd, and now we have new data. Okay, so the first part of this data seems to work, of this pipeline, sorry, seems to work. So we'll just put a nice sticky note behind it to say first part, basically trigger and search source data. Tuk, and voila. This is the first part of the pipeline done. Boom. So if we go back here, we've been able to do that. And now let's pause and to see what we have to do next. Okay, so for the second part, so once you have your, because the experience with n8n can be a little bit raw, right? We are just dealing with raw data, and of course you will always need to have some validations and dashboard, etc. So this is why I was showing you earlier the Streamlit applications. Basically, in the code, the Streamlit application, you will see that your Streamlit application is using your API. You can use your API, of course, and to extract the data from your API and to build a dashboard on top of it. So this is exactly what this application is. So let's say August 2024, the 3rd, we've already tried that. So basically we are replicating poorly what Google have already done, but it's okay. It's just to visualize the paths of the hurricanes, the track ID of each hurricane, the number of data points that we have, the category, etc., etc. So with that small dashboard, you can validate your pipeline as well, which is nice. Okay, for the second part, so what do we want to do for the second part? We want to format the data, and we want to create this API, the in-house predictive model, right? So for that part, I will just show you what you need to know. But since we've already developed, I already showed you how to develop the first API, we will move a little bit faster here for the second one. Now, for your predictive model, at some point you will have a macro function or the main function that will generate one scenario, one forecast, or one number, okay? And as we did earlier, you need to encapsulate that logic into your API. So if you remember correctly, here, this is the second API that I have built for this demo. In terms of abstraction, let's say you have your predictive model. Here it's a risk calculator. And your predictive model basically is using the hurricane data as an input and to compute, the risk profile. So as I said, the number of people traveling to some airport that will be in the path of the hurricane, this kind of stuff. So that function is completely a Python function, but I'm encapsulating it into this router.post. And I also have this my main with my fast API. So when I do all of that and all the parameters, blah, 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 I'm encapsulating basically my logic into the API. So I've already set up this API in Railway. So let's look at what this API look like. So this is, this is not this one. This is this one. So in this API, I have basically a description which is saying, hey, as an argument, I want to have here, this is the records of the path, the hurricane data, and I also want to format the main body of the request that way. So I need to keep that in mind, and I need to format the data so that I can send the request in the right format. Now, it's very, very common when you have multiple systems that you need to format data. So it's good to know how you can do that efficiently with n8n. So, as we said, let's see. All right. So now I have my data, and as we've seen, we want to create your HTTP request again. So I think it's post. Yeah, for the sake of the video, I'm showing you how to parameterize it. So basically, you can also take the curl, as mentioned. I just want to speed up a little bit. So you have the URL of the second API basically, which is this URL here. Then you need to send some header, accept application, content type application. The application will tell you that. Yeah, some applications here that you need to have. Then you send the body, and the body will be what we've already prepared in the previous step. So in the previous step, we are preparing the body of the request with the start date, days, data, everything formatted correctly. And when you execute it, you should be good to go. So let's retest the pipeline entirely. Yeah, okay. So now we have, look at that. The second API, which is sitting on top of our predictive module, is giving us, the number of people at risk, the number of airports affected, and it looks very familiar with this one, because this is exactly this dashboard is using the same information. So you have one date here, 2024 08 03. You extract it, and basically this dashboard, the Streamlit dashboard, is doing exactly is displaying this is the visual element, right? So so yeah, it start to work, everything start to fall in place. So this is the second API on top of the Actuarial forecast module. Okay, something like that. Then we are almost done what we want to do just in the end is to do some triage. So we'll use a switch. The switch are very simple but powerful tool where basically based on some value, let's say the number of people at risk, and I will create a dummy rule if it's less than, okay, let's say 50,000 people traveling. I will say it's a low risk, and if the number of people at risk, where is it? Yeah, here. People at risk is greater than or equal to 50,000 with high risk, okay. What is good with the switch in n8n is you have the name here of the branch. So when you are visually looking at your pipeline, you see, okay, you have some names, and you can speak to humans basically. So switch, this is our triage. If we remember, we have the triage here, and then we need to send one email. So let's say if there is low risk, we do nothing, or we throw an error, or we stop. So there is multiple scenario. I won't implement a scenario here, but I will only implement a scenario when it's a high risk. When it's high risk, basically you want to use, I will use Gmail, but you use whatever mail services you want, and you want to send a message. Okay, so let's say you send a message to me. Please ops gmail.com. Subject risk. Okay, and now you want to format the email in a way that makes sense. Again, I will copy paste the solution, and I will explain what I've done here. But basically, you write your email and you say, hey, our model show critical risk exposure as of, and you put the date. So basically, you take the date here, and you can go copy paste it in your email. Then, remember, I wanted to have all the list of the airports. I wanted to have something like that. So the email will look like like something like that. Again, I'm not an expert in HTML. I just asked ChatGPT to help me with that piece of the project, right? But this is the way you do it. You have your list of airport at risk. Here, this is the list of airport at risk. Have Boston, have Los Angeles, or LaGuardia, sorry, Philadelphia, I believe. And you map with the airport code and airport name and the number of people at risk. Okay. So once you do that, we execute the step. Boom. And I should have received one email. Let me see. Okay, I just received the email. And voila. So we have our pipeline up and running in n8n. So let me show you the cleaner version, where is the trigger, the leverage of your predictive model, and the way that you can send some message to your team. So let's wrap up. During this session, we've seen many components, technical components. Thank you for listening to that. If you have any questions and comments, especially where I went a little bit fast regarding how you can turn your Actuarial predictive model into an API, because that is your secret sauce. Once you know how to develop one API, it's super easy to do that on top of your predictive modules in Python. But if you need help, or if you need me to deep dive into some components of this presentation, just let me know. You can go to LinkedIn, basically. You find me on the Stefan Further, and I will be happy to follow up with you and to continue the conversation offline. Other than that, I wish you happy end of your day. Bye bye. See you next time.